Okay, so we're going to be reviewing some of the simple machine math that we introduced. And the first question that we're going to start with is when the problem is giving you the object's weight, or rather the object's mass instead of the object's weight, you're going to have to find the weight in newtons, which we've done before, but a lot of people are forgetting. So I'm going to start with that. So if I have a 36 kilogram pumpkin, I am going to convert its mass into weight in newtons just using the F of G is equal to M times G formula that we've used before. Remember, F of G is equal to the weight of the object in newtons. This pumpkin has a mass of, 36 kilograms. And we know that G is 9.8 meters per second squared. So we simply do the multiplication and we get 352.8 newtons, because when we multiply kilograms times meters per second, it gives us an answer in newtons. So that's just a reminder on how to solve for the weight of the object in newtons when you're given the object's mass. Okay, second set of questions that you might encounter. One's about work. And so here we have a cart that we're pushing with a force of 23 newtons for a distance of 12 meters. What's the amount of work that's done? So we can simply just use the formula. There we go. Force times distance. And when we do that, we can plug in our value of 23 newtons times a distance of 12 meters. When we do the math on that, we get 276 joules, because when we multiply newtons times meters, a newton meter is equal to a joule. Okay, so those are some reminders to sort of get you thinking about the things that you need to know in order to solve some of these problems. So let's take a look at our first one. We are given the input arm distance and the output arm distance, and sometimes it's really helpful to just label your diagram so that you can remember, okay, this is DI, this is DO, and we're solving for mechanical advantage. And in this case, it's going to be ideal mechanical advantage because we are given the values that we can use to solve for that. So, and you'll notice I'm not putting in all the Dilts-House steps right now, just because I want to make this video as short and sweet as possible and informative. But yes, of course, you should be listing your variables and so forth. Okay. So I have 16.5 meters as my input arm distance, and my DO is 3.3 meters. And because I have meters on top and meters on the bottom, my meters are going to cross cancel away, and my IMA is going to be equal to 5. And remember that mechanical advantage is a unitless value. So that is fine that our answer came out with no unit. All right, so for our next one, we now have been given both the input arm, the output arm, and we've also been given the weight of the object in newtons, which is our force output, and we're being asked to solve, in this case, for the force needed to lift this object. So we're solving for Fi. So using the values that we got from the last problem, we know that we already solved for IMA, right? And now we're going to be solving for part of the mechanical advantage. And just kind of recall that IMA again is DI over DO, and mechanical advantage is FO over FI. But we've already solved for IMA, right, in the last problem. So we don't need to waste time plugging in all those values again. We can simply put in the IMA that we got. So we have 5 as our IMA. And we also know our force output value right now. So we're really just going to be solving for Fi. So in order to do that, though, we're going to have to get Fi all by itself, right? Because right now it's on the bottom of this side of the equation, and we want to move it. So just to demonstrate, and I won't do it on the next one, but on this one, just to demonstrate as a reminder how we can get Fi by itself. If I want to move everything over, I can multiply Fi on this side so that it can cross cancel and go away. If I multiply it on that side, I also have to multiply it on this side. Now that I've gotten Fi to the other side of the equation, I've got to get this 5 to move over. So now I can divide by 5 on this side, which means this will cross cancel away, but that means I also have to divide by 5 on that side. And so what I'm going to end up with as my final equation then is going to be Fi is equal to Fo over 5. So now I can plug my values in. Fi is equal to 45 newtons. That's my force output value over 5. And when I do that, I'm going to get an answer of 9 newtons because my newtons is just going to stay with me. And this is a unitless value, so the newtons ends up over here. Okay, so that is an example of how you can use all of those formulas. The formula for calculating the weight of an object in newtons, the formula for work, as well as calculating IMA and then using the IMA to help you find one of the force values with the understanding that IMA is equal to MA. If you have any questions, feel free to stop by in Purpose Period and let me know.